on. You should be writing this down. You got this written down? I thought this was a new objective.
You guys are only supposed to write the first one. Or did I tell you to write both? I did. Oh, well, y'all good then. Bless the children. And bless the teacher. All right, sugar plums. But can y'all do me a favor? Can y'all put March 16th and then write the second one? Because that's when we're actually fulfilling the objective. Okay? Or you could just write beside the second one, March 16th. All right, Sugarfoots. Today's date is March 16th, and we will be fulfilling the second objective that you all received yesterday, okay? Today, you guys are going to be learning how to determine the maximum and minimum values of a function. Now, young people, just that. What does maximum mean? Highest, right? What does minimum mean? Lowest, okay? Now, when you're dealing with a graph that looks like this, got a whole bunch of squiggles everywhere, right? You have many points of maximum and minimum, okay? Kendall, why are you sitting right there, baby? Okay, so you don't need a phone for the lesson? Set that phone over there and relocate because you can't see the board. Relocate. You see all these squiggles everywhere? Okay, all these peaks and valleys, okay? And when you have a graph that has multiple peaks and valleys, that is an instance where you will have something called a relative maximum value and a relative minimum value, okay? Now, a relative minimum value is essentially the lowest point in a region, okay? The lowest point in the region on a graph, okay? Yes, please. And also, the relative maximum in the same vein would be the highest point in the region, okay? Highest point in the region. So this graph has several instances of low points. Here's a low point here, low point here, low point here. All three of these points, young people, would be considered relative minimum values. Okay? Relative minimum. All right? And then all of the peaks would be the relative maximum values. Any questions? Shantasia, put your phone in your bag. What are you doing? You were doing something. I believe you, but you were doing something. You got this written down? Both of them? Okay. May I proceed? No? Okay. You good? Anybody else? Grayson, I'm waiting on you. It's cool. No, you're good. Let me know when you're done, okay? Elijah, are you done? Let me know when you're done, okay? Please, thank you. Michael, sit up, baby. Don't want you having a meeting with the Sandman. All right. All right. All right, young people. Now, there's also something called an absolute minimum and maximum value. Who can tell me what that word absolute means? Exactly? Okay, I'll go with that. Exactly. To give me a stronger word than exactly. The most. Have you guys ever heard this quote that states, absolute power corrupts absolutely? What is absolute power? Complete? Power over what? Power over everything. Can't nobody tell me nothing, right? Absolute power corrupts absolutely, meaning that anybody, they could be the sweetest, purest, nicest person in the whole wide world. If you give them absolute power, they will become corrupt eventually, right? You all said that absolute power is power over everything. Well, overlay that sensibility onto this mathematical concept. Absolute minimum value. That means the rock, absolute, okay? There's no, can you have more than one absolute anything? No. So if there is an absolute minimum value on a graph, it's going to be the only one lowest point, and there's not going to be anything beneath it, okay? And thus is the same for the absolute maximum value. The absolute maximum value will be the highest point, and there will be nothing above it. Does that make sense? Okay, so the text states an absolute minimum value is the absolute lowest point. Nothing lower. Okay, and the absolute maximum value is the absolute highest point. Okay, nothing higher. I'm surprised y'all didn't hear that quote in your history classes. Have you all studied World War II yet? I'm glad you passed. That's typically when that quote comes up. You know, when they're talking about, you know, people like Hitler and Mussolini and the like. Y'all talked about them during that? Never mind. This is math. I'm going to stay focused. Absolute power is a dangerous thing. And of course, we're about to look at examples for both of these concepts, okay? May I proceed? Okay. Anybody else? All right, y'all, let's go. So look at this graph, y'all. Okay. Now, we've been talking about graphs shaped like this for a while, okay? And please be reminded that that portion of the graph, they can only show us a snapshot, right? Remember, it goes on and on and on and ever, forever and ever on that side, and then it goes down and down and down forever on this side, right? Now, in this case, we would have a relative maximum value here and a relative minimum value here, okay? Relative maximum. Now, why is it not an absolute maximum? I'll tell you. Because we have other higher points, right? There is something higher. But right here, round about this part of the graph, okay? Round about this part of the graph, I have a maximum value. And over here, round about this part of the graph, and yes, I did say round about because I'm from Pensacola, Florida, and that's how we talk, okay? That's all right with you. There's a relative minimum. But is that an absolute minimum value? Because you see this arrow, and you know this arrow means I got some more stuff down this way, right? Okay, so we only have a relative maximum value, and we only have a relative minimum value in this case. So what you're looking for is peaks for relative maximum value and valleys for relative minimum values. Does that make sense? Okay. May I proceed? Okay, it's very intuitive. It makes it just, it is what you think it is. Okay, you don't have to twist your brain in any kind of way. All right. Now let's look at this example here. Let's reach in the back pocket. Let's talk about domain again, y'all. What's the domain of this function? Excuse me? To where? Say it louder for the people in the back, baby. You are absolutely right. Young people, remember, the domain of a graph of a polynomial is going to be negative infinity to positive infinity. I know they have all reals, but this is what I want you to write. Negative infinity to positive infinity. Well, no, because I'm going to give you something. You're going to have to do this, but just make notes, okay? Let's just review these topics, because it's just not going to make sense for you to just write it down and I have a picture to go with it. You feel what I'm saying? But I got you, though. I got, no. You're going to write it down. Look at the back of the sheet that I gave you. You're going to write it down, I promise. I got you. I got you. I got you. Okay. Now, what's the range here, folks? Remember, the range is the collection of all possible y values. What's the lowest possible y value? -4? That's the lowest possible? Are you telling me the graph stops right here? That's what you're telling me. Because if you tell me the smallest value is -4, you're telling me the graph stops right there. I could have sworn I see some stuff beneath it. And I hear you, babe. I heard you say negative infinity, and you're absolutely right, Kendall. Okay? So the range would be from negative infinity to where? Positive infinity. Does that make sense? Hello? All right. Remember, didn't we do numbers 1 through 4 together? That's all this is. Only thing new is 5 and 6. Only thing new on here is 5 and 6, y'all. We've been talking about everything else. Come on now. Get it together. All right. Now, the zeros. How do I know where my zeros are? And where it crosses where? The x-axis. Yes. So we have one here and here. Now, I'm going to take this opportunity to talk to you guys about something called multiplicity. 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 What do you think multiplicity means? More than one, multiple, right? Okay, multiply, multiple. Okay, Elijah, need your attention, baby. Now look, do y'all see how this curve kissed the x-axis right here? Let me pan in. You see how it kissed it? Okay. Whenever you have a polynomial shaped like this, and we're going to dive deep into these types of graphs tomorrow, but I need you all to understand something. We have the element of multiplicity when your graph kisses the x-axis like this. Because technically, if this curve was shifted up, this is what it would look like. Oops. This is what it would look like. And y'all, this is going to be ugly. I apologize. It's about to be real ugly. Normally, it would go up, down, up, okay? And how many times did this curve cross the x-axis, Elijah? How many times? Hello? 3. This is the graph of a cubic function, okay? X cubed something, something, something. I don't know. It's ugly. I don't know what the equation is, but I know it's cubic because it's supposed to cross it in 3 places. So let me erase this foolishness. The graph that you see here technically should have crossed the x-axis in 3 locations, but because it's shifted downward a bit, my curve only kisses the x-axis in this one place. So what we have is the element of multiplicity at -2, okay? So I have 2 zeros at this point. Yeah, just a second. I have 2 zeros at this point. I have -2, -2, and 1, okay? Yes, ma'am. Yeah. Yeah, she's gonna miss it. All right, thank you. Mr. Bright's gonna make the change. All right, Jania's, she's marked absent, but she, well, I don't know if she rechecked it. Okay. All right, so these are our zeros now, y'all. Normally, because I've just been telling you, okay, where it crosses the x-axis, normally we would just say -2 and 1. And technically, you're right. That's where it touches it. But because we're dealing with a cubic function, Elijah, baby, take your jacket off. You too warm and cozy, baby. Take your jacket off. All them Jolly Ranchers you ate, it seemed like it would have pepped you right on up. Huh? Should have pepped you right on up. Should have pepped them right on up. All that sugar. A little rusty. All right. But because we have the element of multiplicity, y'all, okay, I have 3. I should have 3. -2, -2, and 1. Y'all with it? And this only happens when the curve kisses the x-axis like that. When there's a turn in the graph and it just touches the x-axis, when it just kisses it ever so slightly, okay? Multiplicity. We cool? Why not?
I know you got -2, but I need to.
Okay, because you were napping when I was explaining it, but I'll do it again.
I see.
Imagine, yeah. No, that would be the y-intercept here. Remember, the zeros is where it crosses the x-axis, right? And I told you guys to imagine if this curve were shifted up, okay? If it was pushed up, what would this curve do? Well, it would go up, down, up, like that, right? Touching it in 3 places. Technically, it should touch it in 3 places because this is a cubic function, and that is the nature of a cubic function, okay? But in this case, it's been pushed down, and it's kissing the x-axis in 1 place. So I have the element of multiplicity in this 1 location. That's why we listed it twice, okay? I need you to stay awake, for real. All right? All right. All right, moving on. Y-intercepts. We just talked about the y-intercept. What's the location of my y-intercept, y'all? Just -4. All I'm gonna put is -4. Thank you, Elijah. There you go. Okay. Hold on, let me erase my writing because this is all typed in. Hold on, you guys. Okay. Remember, the intercept is the actual location. -4 is the y-intercept. That is where it's located, but we need to name the location, name the coordinate, okay? All right. Now, look at this graph, y'all. Let me erase all this foolishness I got drawn on here. And tell me something. Do I have an absolute maximum or minimum value? Is there an absolute highest point? Who do you think it is? Infinity. Good answer. Now, let me tell you something. Because the highest point is a theoretical infinite number, okay, there is no absolute value. Because if you said that the absolute value was infinity, I would say, what about infinity plus 1, right? So in this case, if you can see that the graph goes up and up and up and up and up forever, there is no absolute maximum value. Now, on that same vein, in that same vein, is there an absolute minimum value? It's headed down to where? Going where? Negative infinity. Thank you. Negative infinity. So because it's headed down to negative infinity, the same answer. There's no absolute minimum value either. So there will be no absolute max or min. Okay? Yes. This is an emergency. It better be if you interrupt my instruction again. Hurry up. You're missing something. Act like it's an emergency. Me too. If it was an emergency, I'll be running out of here. Emergency, my eye. All right. Now, but do we have relative maximum or minimum values? Yeah, we do. Round about right here, right? In this region of the graph, I have a peak. Okay. And when we name our relative and maximum and minimum values, guys, we use points to name them. Okay. We have a relative maximum at this point. What's the location of that point, guys? Okay, -2, 0. And what's the location of my relative minimum value? Because round about right here, I have a valley, right? And that location is 0, -4. Okay? How we feeling? All right. Now let's talk about this increasing and decreasing, okay? Valeria, you with me, baby? All right, look the part, sugar. I'm gonna put some notes on here, okay? I got increasing here. I'm increasing here, right? Sorry, y'all, I'm writing all wobbly. Okay, and I'm decreasing right here, right? All right. So I have to name the intervals within which this function is decreasing, Kendall. Okay? I say Kendall. Bless her heart. Come on, sugar baby. Take your jacket off too. Y'all too cozy. Y'all think y'all at a slumber party. So this first portion here, between which two x values is this function increasing? Look at the screen, y'all. Well, let me ask y'all something. Where does it stop increasing? I said, where does it stop increasing? Just on this part, y'all. Just on this part. Just on this section. At negative, okay. All right, so I'm gonna circle it. All right. So that means wherever it stops increasing, that means -2 is gonna be somewhere in my answer, right? Now, question: where does it start increasing? From negative infinity. Oh, okay. Let me highlight what y'all just said. Starting somewhere back here, right? Way back here, coming over, reading the graph from left to right, right? My graph keeps going up, but it stops doing that at 2. So how do I name this as an interval, Savage? Thank you. Negative infinity to -2. Now, I have another area where I have increasing values of my function, right? Because that's a turning point. Because theoretically, think about it like this. If I put a bracket on -2, I would be both increasing and decreasing at the same time. Okay, so it's a pivot point, so we would just capture it with a parenthesis. Okay. I'm going to say this. If you put a bracket, I would not mark you wrong. Okay. But I'm going to put a parenthesis. All right. All right. Because technically it's not wrong. Okay. All right. So now, young people, let's look at the other area where my function is increasing. Where does it start to increase? At -4. Okay. All right. -4. Right here at this point. But I choink up to the x-axis. This is really where it starts increasing. You feel me? Because when we're naming the interval of increase or decrease, we only use the x-axis. So let me get my highlighter. This is my starting point. Now, where does it stop increasing? Stop it. It keeps going up, right? As I go to the right on the x-axis, the graph keeps going up, 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 up forever, right? So that means, okay, don't forget that funky looking U, right? What does that U mean again? Mm-mm. Say it. Somebody said it. Say it louder for the people in the back. This little funky U means union. Remember we talked about that yesterday? So you're going to put union with the other interval, which is going to be 0 to positive infinity. Not the -4. Not the -4. We use the x values to name our intervals, okay? All right. So with that being said, between which two values, well, let me ask you this. Where does this function begin to decrease? Oops. Where does this function begin to decrease? Where? At -2. Okay, cool. Where does it stop decreasing? At -4. So you telling me it's decreasing back here? Look at where it's decreasing, right? Remember, we read the graph. Oh, you're looking at the y-axis. Remember, did we look at the y-axis to determine our interval? Oh, no, no, no. Curse word. I didn't mean to do that. Hold on, y'all. Yes, I did. Thank you for asking. Hold on, sugar babies. Gotta put that back. Remember. We use the x-axis. Between these two values, my function is decreasing. Do you see? Does that make sense? All right. And how are we going to name this interval? Y'all better tell me something. -2 and what? And 0. Boom, done. Not -4. Okay, Elijah? Not -4. May I proceed? Let me erase my writing because it's on here. All right, let's look at this one. I wonder what the domain is. Jamari, what is the domain? Whatever could it be? Come on, Elijah. Thank you, sugar baby. From -infinity to positive infinity. The thing is going to say all reals, but y'all know what's up, right? Let me write it out to the side. All real numbers is -infinity to positive infinity, okay? Not yet, not yet. You friend too. Hold on, I promise. I got you. All right. Now, Emma, what's the range? Do I have a bottommost value on this graph? Remember, the range is all possible y values, so I'm actually looking at the y-axis. What is the bottommost value of this graph? -4. So that's going to be my starting point of my range. I hear you, Michael. Okay. Now, on this here range, because -4 is the absolute lowest point, hint, hint, wink, wink, nudge, nudge for later on. Okay. I'm going to place a bracket around -4. Okay. Now, with that being said, if I got my bottommost point, what's my highest most point? Infinity, because it keeps going up and up and up and up forever, right? That's ugly, but whatever. I did. Whatever. Oh, man. Bless the teacher, because I'm going to try again. There you go. All right. Now, what's up with the zeros, y'all? All right, -2 and 2. Now, do I have the element of multiplicity here? Why not? because the curve isn't kissing the x-axis. No, so it's already moved down and there's no curve touching the x-axis in one place, right, Elijah? Okay. What's that? Right, Jaden? Thank you. Okay. Blink, blink, blink. Autumn Jolly Ranchers. You should be, you know, like the little power up on Super Mario. Blink, 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 blink. Get you a Jolly Rancher. All right. So let's talk about the y-intercept. What is the location of my y-intercept? Just -4? Wrong. Thank you, sugar baby. That was supposed to be an X, but whatever. That's what I get because I was trying to be funny. All right, so remember, when you're naming an intercept, they want a point, okay? So that would be 0, -4. All right? Now, number 5 is asking for an absolute maximum or minimum value. Do I have a highest point here? No, so no absolute max. Do I have a lowest point here? Yeah. Where's the locator? At -4. And remember, we name absolute maximum and minimum values using a point, a location. Okay? 0, -4 is the location of my absolute minimum value. Okay? Any questions or concerns? And if I have an absolute minimum value, I naturally would have a relative minimum value. But understand this, it doesn't work in the reverse, okay? If you have an absolute minimum value, you automatically have an absolute minimum value, okay? I'm sorry, a relative minimum value. But if you have a relative minimum value, that doesn't automatically mean that you will have an absolute minimum value, okay? And I think we saw that on the previous slide. We had a relative minimum and max, but no absolute at all. You feel me? All right. So the location would be 0, -4 as well for the relative minimum value. Okay. So where's this function increasing, y'all? It's increasing right here, right? Increasing from where? 0 to infinity. Very good. Very good indeed. Bless the children. Because this is the point where it starts, right? That's where it starts. But we wouldn't say -4 is our starting point, would we? We would shimmy up to the x-axis. All right. So I am increasing from 0 to positive infinity. Now, where is my function decreasing? Let me label it. Decreasing. Okay. What is my starting point of my decrease? Say what? That's what I hear. I don't know what y'all saying. -2 to negative infinity? Which number is smaller? There you go. There you go. Negative infinity. You said the 2? See what had happened was. But y'all know what you meant. I heard 0, but you said 2. It's cool. Does that make sense though? Okay. Same point. Okay. It increases. The decreasing ends where the increasing begins. Okay. Right, David? Come on, y'all. If I can't sleep, can't nobody sleep. I'm tired too. Sit up, Emma. Sit up, Jamari. Shoot. Little resty kids. Turn to number 7 on your worksheet. 7, 8, 9. Feel free to work with your seatmate. I'm going to give you guys 7 minutes. Hey, Google, set a timer for 7 minutes. 7 minutes? Off the chain. 7, hold on. Google's cutting up. Hey, Google, set a timer for 7 minutes, please. There we go. Thank you, sis. Seven, 8, 9, y'all. 7, 8, 9. And we're going to talk about them momentarily. Gonna go ahead and cue number 7 up. Be careful, look very carefully at the blanks, because they changed some stuff up from problem to problem. They're not all identical, okay? Be careful. All right, folks, let me make sure my microphone is back on. All right, we're cooking. Okay, let me share my screen or project my screen. All right, y'all. So let's talk. On your paper, now that you have a graph in front of your face, right? Hold on, let me get the draw. Set up my pens, highlighters, and things. Let's write this one. Oh, that is not what I want. All right, there we go. All right, sugar babies. First thing I'm gonna do, and if you didn't do that, you need to do it. Especially if you're having trouble, go ahead and label the portions of your graph that are increasing and decreasing, okay? I have increasing here, and it's increasing here, right? All right, and it's decreasing on this snack piece here. Okay? All right, cool. Now let's look at the first area of increase, right? First of all, remember that this thing goes down and down and down forever, up and up and up forever. So where does it stop increasing? Where does it stop increasing? At this point right here, right? Where it stopped? You said -2. Why did you say -2? Bless you. So look, say that point didn't have a coordinate, because you on your test, you may have a point that doesn't, you may have a graph that doesn't give you the coordinates. Wherever it stops, you need to train your eyes to travel down or up to the x-axis, because that value is going to be a part of your interval in some kind of way. Now that's where it stopped increasing, right? Where did it start? At negative infinity, okay? It started out here somewhere, so let me highlight these areas, okay? Starting here, going back. Oops, back this way, right? So when I write in my increasing interval, I'm gonna say from negative infinity to -1.33 is my first interval. So because I have a second interval, I'm gonna put that funky little u there, right? And what does that u mean again? Union, okay? Because I have two areas where my function is increasing, all right? Janiyah, you're back? You're back? Yeah. They called her in the attendance office, yeah. Yeah. That's what that's
I thought Ms. Bunting, I thought you said you had a junior attendance.
yeah, but she
And I said, what did I say? I said, let's go. And you said, no. I said, let's go to that one.
excuse me. I beg your pardon. All right, y'all. So on the second portion of the graph, where does it begin to increase? At 0, right? It starts increasing here and then it goes out. As x gets bigger, my y values are getting bigger, right? Okay. So what is the second interval? I heard someone say it. Starts where? And goes out to positive infinity. All right. So now, young people, I see a gap, and in between that gap, I see a portion of my graph that is doing what? That's decreasing. Let me change my color so I can highlight it, so I can make it pretty. Between these two x values, okay, my function is decreasing. Where does this function begin to decrease? From negative 1.3, 1.33, thank you. And where does it stop decreasing? At 0. And remember, when we're increasing and decreasing, we look to our x-axis, okay, to develop our intervals of increase and decrease. All right. Now let's look at this concept of the constant. Young people, yesterday I taught you guys how to algebraically find your y-intercept, right? And I told you to plug in 0 for x. Hold on. It's cool. I told you to plug in 0 for x, right? Because you're going to tell me this. After we did all that work, plugged in 0, pared it down, simplified it, the value that we got was the same as the what? In the equation. Maybe I need to write an equation. If I had y equals x cubed plus 3x squared minus 4, and we plugged in 0, right? Paired it all down, and we got -4 as our y-intercept. And I doubled back and I said, what do you notice in the equation? It's the same thing as the what? The constant value is the same thing as the y-intercept. Whatever the y-intercept is, so is the constant value of the function. Okay? They're asking you for the constant. So, oh, I see what you're saying. No, not here. I see what you're saying. So what is the interval of constants? So if that's the case, there is none. I'm not mad at that. I'm not mad at that. I'm not mad at that. Okay? But what is the constant of this function? -4. I'm gonna say no, of that function. Yeah, let me erase this. I pulled this out the side of my neck. It's 0. Okay. All right, so what are my zeros? -2 and 0. I got one more. I got another one, but it ain't -2. Say it again, Marion. 0. Marion, why is it 0? Because it's kissing the x-axis. Right? It's kissing the x-axis right here. Is it kissing it at 2? I mean, at -2? So there wouldn't be multiplicity there, right? All right, what is the y-intercept? 0, 0. Very good. Is there an absolute minimum or maximum value? Okay. Is there a relative minimum or maximum value? Excuse me? Oh, that's right. That's right. For relative minimum. It is located at 0, 0. Thank you, baby. And the relative maximum will be located at -1.33. And what is that, 1.19? All right. May I proceed? All right. All right, number 8, okay? And I'll make an adjustment here, young people. You all will have to learn that skill, and that's why I was doing what I was doing with telling you about the y-intercept and all of that stuff. But is there any constancy on this graph? None. Come on, what are you doing? Hold on, sugar, hold on. Let me set this up so I can focus on you, okay? Okay, talk to me. There won't be any ambiguity. So if I want to know the constant of the function, I will say constant of the function instead of just constant, okay? Does that make sense? All right. So the graph has no constancy at all, okay? But in keeping with what I just taught you or what I just pointed out, what would be the constant of the function of this graph? I beg your pardon? What would be the constant? It will be 5. 5. Okay? Questions or concerns? 5 would be the constant of this parabola. All right. Yeah, I can. So remember yesterday when we were when I taught them how to find the y-intercept? Okay, and I'm just gonna write some arbitrary equation. F of x equals 3x cubed minus 4x squared plus 6, right? And they plugged in 0 for x, all right? And they found that it was 6. Well, then remember when I pointed out, hey, what is this the same thing as? The constant. The constant in the function is the same thing as the y-intercept of the equation. Yes.
Which fiber are you talking about?
This one. The y-intercept. Okay? The y-intercept. It crosses 0. Alrighty. Moving on now, I'm gonna label my picture, y'all. I'm increasing over here, right? And I'm decreasing over here. Feels so weird. Right? So at what point does my graph begin to increase? Like put your finger on the point where the thing starts to go up. 3, -4, that's the location, right? Now, from that point, I'm gonna shimmy up to the x-axis because they may not give you the coordinate. I know that this is going to be the starting point of my interval. Curse word. I know that this is going to be the starting point of my interval, right? And it's going to start there and go out this way. So how do I name this interval? Starting at 3, ending where? I beg your pardon? 0? Baby, we're on the increasing. Okay, so we're going to start at 3, and we're going out to positive infinity. You with me, Elijah? All right. So now, looking over here, the same point where it starts increasing is where it stops decreasing, right? So looking at this graph, I know that 3 is going to be in here somewhere, right? Let me change my color. So there's the point, shimmy up, shimmy up, shimmy up. This is where I start to decrease. But where do I begin to decrease? That's where I begin to decrease? Negative infinity. Be careful, not -4. Where'd you get -4 from? Oh, here? Focus on the x value. Okay, focus on the x value. Focus on the x-axis. Now, -4 is the point, part of the point where it begins to decrease. But what is the x interval? Okay. So where does my function begin to decrease? Remember, these arrows go up and up and up forever, right? So as this y value is getting bigger, so my x is getting smaller. So I'm starting at -infinity, right? And ending where? At 3. Okay. Do you have that? All right. What are my x-intercepts? I beg your pardon. They asked you for the x-intercept. Come on. It's a little tricky, right? Because in the previous question, they asked you for the what? They asked you for the 0. So it's cool. If they ask you for the zeros, it's cool to say 1 and 5. Okay? But be careful. That's why I said that she was wrong, even though she's right, but she's wrong, but she's right, but she's wrong. Does that make sense? Because when they ask you for the intercept of any sort, you got to name a what? You got to name a point. There you go. So it's going to be 1, 0 and 5, 0. But if they ask you for the solution, the root, or the 0, you can just put a singular number. We clear on that? All right. Savage, sit up, baby. Kendall, thank you, baby. Okay. Y-intercept. 0, 5. Do I have an absolute minimum value here? Where's that location? 3, -4. That's all I got? Dang. No, it's cool. Do I have an absolute maximum value? Infinity. So if it's infinity, we're going to write none. You okay? You guys about to say write infinity. You better hop out the window, winner. And so naturally, young people, if I have an absolute minimum, I also have a relative minimum, right? 3, -4. But since I have no absolute maximum, I naturally have no relative. Well, that's not true. That's not true. But in this case, do I have any relative maximum values? No peaks at all, okay? All right, y'all, I'm going to fly through number 9 so that you can just check your own paper, okay? Going to fly through it. All right. This function is increasing from, come on. Get it together, girlie. All right. It's increasing from -1 to 0.219 in union with 2.28 to infinity. All right. It is decreasing from -infinity to -1 in union with these some ugly numbers, 0.219 to 2.28. All right. The constant value is located at 3, or the constant value of the function is 3, but is there any constancy? None. The solutions would be -1, -1, 1, and 3. Okay, notice if they say solution, you just get the straight up number, okay? The y-intercept is located at 0, 3. Absolute minimum, there are none. Oh wait, I'm lying, I thought I said max. Absolute minimum is located at 2.28, -9.91. Absolute maximum, there is none. Okay, relative minimum values would be 2 locations at both -1, 0 and 2.28, comma, -9.91. Relative maximum, there is 1 location where I have a peak, and that location is 0.219, 3.227. All right, now, y'all have homework. Y'all have to complete this whole worksheet. The whole thing. Okay. Sit up, baby. What you mean? Careful, child. Careful.
Homework, Bob. Don't about bringing your. You.
I ain't trying to keep my notes. That's not my bad. So, leave me alone, little boy. I'm gonna ask you what you want. This ain't Burger King. Can I give you one that? Somebody I don't want it. I gave it to him. All right, let me turn this recording off.
Folks, I'll be here today if we need to.
Excuse me. Excuse me. Wait, ain't nobody leaving till she go back to her seat and sit down. Ain't nobody leaving. Ain't nobody leaving. Cause she thinks she's slick. You see her? Talking about some putting the fidget smell in her bag. You can move in if you want to, bye. Huh? See y'all tomorrow, and you better do your homework too. What? Oh, Marianne, you can stay mad too. She can stay mad. All right.